Building a large drone capable of spraying water for irrigation is an ambitious and rewarding project, combining mechanical engineering, electronics, and innovation in agriculture. Although it may initially seem complex, when broken down into steps, the process becomes manageable, logical, and very engaging. Whether you are an enthusiast, a farmer looking for creative solutions, or a drone lover, understanding the design and construction process is essential. Below is a comprehensive guide on how you can create a large drone specifically for watering plants from above. Start by considering the goals and requirements for your drone. This device must be capable of lifting and carrying a significant payload, namely water, while maintaining the stability and precision necessary to effectively spray pesticides on crops. Key criteria include load capacity, flight time, range, and accuracy in water delivery. The first step is to choose or design a sturdy aircraft frame. For a water-spraying drone, you will need a large, durable frame, usually in a quadcopter or hexacopter configuration. These designs balance lift and stability, making them ideal for carrying heavy loads. Carbon fiber is a popular material due to its high strength-to-weight ratio. Aluminum and fiberglass are alternatives, but lightweight is always prioritized without compromising durability. Once the airframe is selected, move on to the propulsion system. Power is very important because every additional kilogram of water will require greater thrust. Choose a high-torque, brushless motor combined with large propellers with an efficient blade angle. Typically, large drones use propellers ranging from 17 to 30 inches. Your electronic speed controller, an ESC, must also be rated appropriately for both the motor and the total expected current throughout the flight. Next is providing power for your large drone. Lithium polymer and LiPo batteries are the standard in drone technology due to their high energy density. For heavy payloads, you will need high-capacity batteries, possibly in a 6S or 12-VIS configuration, to provide sufficient voltage and current. Balance is very important. Larger capacity means heavier weight, so optimizing flight time relative to payload is essential. For reference, many commercial agricultural drones achieve flight times of 10 to 20 minutes per battery, although this varies depending on the payload. The water supply system is the next important component. This system includes a water tank, a pump, an appropriate piping system, and nozzles. The tank should be made from lightweight, waterproof materials, such as plastic or carbon fiber, securely mounted near the drone's center of gravity. Standard tanks have capacities ranging from 2 to 20 liters, depending on the intended use and the size of your drone. The pump should be electric, high flow, low pressure, and strong enough to push water through the pipes to the nozzles. Small diaphragm pumps or peristaltic pumps are suitable for most needs. The nozzle must create a fine, uniform mist for the most effective irrigation. Adjustable agricultural spray nozzles allow you to control droplet size and flow rate. Place them on an extendable boom or arm to ensure even coverage beneath the drone. All external piping systems must be leak-proof and securely fixed, as even small leaks add unnecessary weight and can cause the imbalance during flight. Drone control relies on a reliable flight controller. Top choices include Pixhawk, DJI's A3 or N3, and other advanced autopilot platforms. These controllers not only handle stabilization and positioning, supported by GPS and a range of sensors, but also allow programming of waypoints and automation. A dedicated remote controller, transmitter, and receiver enables manual control at any time, an essential safety feature when working with heavy flying equipment. Integrate the spray control system with your flight controller. Many commercial drones use a separate radio channel to turn the pump on or off, or to adjust the spray rate during flight. Consider programmable flow rates based on flight speed and altitude for consistent watering. For advanced setups, add flow sensors or feedback systems to monitor and adjust output in real time, maximizing uniformity and efficiency. Safety cannot be taken lightly. Large drones flying with heavy payloads pose risks to people, animals, and property. Always use propeller guards when possible, and set up geofencing on your controller to prevent accidental flights into restricted or dangerous areas. Backup systems, a second battery, backup communication links, or multiple flight controllers can significantly reduce the risk of catastrophic failure. Once completed, thorough testing is very important. Start with short, unloaded firefights, checking hovering capability and basic controls. Gradually add weight, simulate a full water tank, and monitor engine temperature, battery consumption, as well as structural durability. Only after these tests meet the requirements should you fill the tank and try the spraying system, preferably in a spacious, safe area. Adjust the nozzle angle and pump speed until the desired water distribution pattern is achieved. With the basic hardware and flight arranged, further optimize by programming automated tasks. Map your planting area using GPS. Then let the drone fly along precisely defined routes to ensure even coverage. The automatic return to home function and emergency timer ensure the drone returns safely when the battery is low or a fault is detected. Maintenance is a factor to consider in order to maintain continuous performance. Regularly check for cracks, loose bolts, worn electrical connections, and leaks in the spraying system. Clean the nozzles regularly to avoid clogging caused by mineral deposits or plant debris. Software updates for the flight controller should be carried out carefully after ensuring compatibility. To scale up for commercial or large-scale use, consider modular designs, quick-change tanks or batteries, foldable arms for easy transport, and ground-based charging stations. Precision agriculture technologies, such as cameras or multispectral sensors, can also be added to collect crop health data during flight, turning your drone into not just a watering tool, but a multifunctional agricultural assistant. From the idea to the first flight and beyond, creating a large water-spraying drone is a journey that combines careful planning, practical assembly, and continuous improvement. By approaching each stage with attention to detail, selecting the right airframe, engine, and electrical system, integrating an efficient spraying mechanism, and prioritizing safety and control, you can create a powerful and effective aerial irrigation device. With this technology, crop care becomes not only easier but also more precise, sustainable, and enjoyable, opening up new possibilities for both enthusiasts and professional growers.